Hi, I'm Rodney, and in this video I'm going to get into the nitty-gritty details of how to go from domino reduction to half-turn reduction by reviewing the core corner cases and the edges that go with them.
To get to HTR, of course, you need to bring the corners into HTR. So our starting point is some corner skeleton. I'm not going to talk about how to find a corner skeleton. That's what Hyper-Parity is about. You don't have to use Hyper-Parity. You just have to have a skeleton that works. You can always find a skeleton that uses RUF moves. It can have up to 5 quarter turns on the U face, and in between each U turn you will either have a single move, that's either an R2 or an F2, or a triple move, which is R2U to F2 or F2U to R2. As you execute your skeleton, if you look at the bad corners, they're going to follow the sequence of one of the paths in this diagram. So here I'm showing the way the corners need to look before each quarter turn. You can have 1, 2, 3, 4, or 5 quarter turns. And so for example, if I have 2 bad corners and I'm in the 4QT case, I can set my corners up this way, execute a U move, execute a side move, execute another new move, side move, another U move, and then my corners will be in HTR. Or in fact, I could set them up so that the corners look like this: U move, side move, U move, triple move, U move, and corners will be in HTR. So find a corner skeleton that work, execute the skeleton, and pause. What we're going to do is pause before each U-turn and evaluate the edges before we continue. When we evaluated our edges, we're going to do more than just count them. We're going to also pay attention to how they're split between the U and D faces, because that's going to determine how many bad edges we have at the next quarter turn. So if I'm set up for a quarter turn and I have 0 bad edges, of course a U-turn will get me to 4, and if I have a 4, it'll get me to 0. If I have 4 and they're split 3-1, then a U-turn will get me back to 2 bad edges, and of course if I have my 2 bad edges together, split 2-0, then a quarter turn will keep me with 2 bad edges. But if I have my 2 bad edges and they're split 1-1, then a quarter turn will get me to 4 bad edges. And if I have 4 bad edges and they're split 2-2, then I will remain with 4 bad edges. And there are 3 ways that you can have 2 bad edges. This way I call bars, where they're stacked on top of each other. Another 2-2 bad edge case is this one. I call this bar slash, so that's the bar and that's the slash. And then the third 2-2 bad edge case is where they're like this, so which I call 2-2 plus. So we're going to pause before each quarter turn and evaluate the edges. In the happy case, we don't need to do anything. Our edges will just fall into HTR at the same time as the corners, so plus 0 additional moves. So first priority is just be able to recognize those cases. If you're not in the happy case, you're going to need to fix the edges. And you have 3 possibilities for fixing the edges. You can make a slice, which is going to cost you 2 or 0 if you've got a cancellation. You can do a corner swap, like R2, F2, R2. That's going to cost you 1 or 3, depending on whether there's cancellations. And you can do a full edge permutation, which is generally going to cost you a lot. If it's too expensive to fix the edges immediately, you want to be able to recognize cases where you can fix them later for cheap, where by cheap I mean net plus 1 move using a corner swap insertion that has a cancellation. For example, for a 3 quarter turn case, you might have a cheap fix before the second quarter turn after the first one, for example like that. Or you might have a case where you can fix it for cheap between the second and third quarter turn, like that. The happy cases and the cheap fix cases are identified in the doc as continue. So learn the continue cases, learn the unfixable cases, which are just the lost causes, and then you only have to spend time on the intermediate cases, where if you have the spare moves, you can intuitively fix edges at a moderate cost.
So the 1 quarter turn case is very straightforward. You have to have 4 edges all together with the corners. That's the only way to continue. Anything else has to be fixed. If you don't have 4 bad edges, you have to backtrack, add quarter turns. If you have 4 bad edges and they're split 2-2 plus, then you can fix them with a slice. If they're 3-1, you fix them with a corner swap insertion. And if they're 2-2, then it takes a lot to fix them. You need a full edge commutator. So here's 2-2 bar slash, and it has to be fixed with like an 8 mover. And 2-2 bars has to be fixed with a 6 mover. This is 1, 4, 5, 6, like that. Let's go on to 2 quarter turn cases. I'm going to start with this one. It's more rare and longer, but easier to analyze. This is one where your corners are in slashes pattern, and the solution is U, R2, U2, F2, U. So the happy edge case for these corners is when your bad edges are 2-2 bars. Then you can just solve it directly. U, R2, U2, F2, U. And what makes this this case especially easy is that it doesn't matter where the bars are, because the corners are symmetric. So your bars can be here, your bars can be here on the back side, and either way you can always just solve it the same way. The next best case is edges in 2-2 bar slash. So here's the bar slash, and this is a fix at +1 after the first quarter turn. So I can go U, and then I do R2, U2, R2, F2, U to get to HTR. The case that can be fixed at moderate cost before the first quarter turn is this 3-1. So if I have my 3-1 bars edges here, then I can do a corner swap here to set up my 2-2 bar slash and do the same thing as before. And if I have 1-1 edges, so here's 1-1 edges, then I can fix them after the first quarter turn. So here's my 1-1 edges, and then I go U prime, and now I've got 3-1, and there's another corner swap, and then R2, U2, F2, U. Let's look at the other 2 quarter turn case. That's this one. This is really the money case. It's not too uncommon for your DR to just land here. And if it doesn't, then the most common 3QT and 4QT cases pass through this case. So this is the one that really pays to understand as well as possible. Let's look at the 2 bad edge cases first. Everyone knows that this is the happy case, this trigger where you bad edges form the bars with your corners. You can just solve it U, F2, U. That's the happy case. But let's look at the other cases where you might want to continue even if you're not forming these bars. So first of all, to continue, you have to split the 2 bad edges 1-1 so that you have 4 bad edges when you get to 1 QT case. And the key, so here's a case where you're not forming bars and you have 1-1 bad edges here and here. And this case continues by a U and then F2. And now I have my corners set up and my edges are in the 2-2 plus, which we fix with a slice. That's a slice with no cancellations. So that's a +2. But the thing to note is that the directionality is important here. So my corners are not symmetric like left-right or clockwise, counterclockwise symmetric. So if I have 2 bad edges 1-1 here, it's different from this case where I have also have 2 bad edges, but they're this way. So the difference is here, the U move that I want for the corners brings the 2 bad edges together. And here it brings them apart, and apart is bad. So in this case, if I do my U and I set up my corners, and now my bad edges are 2-2 bar slash, which is one of the worst cases because I have to fix that with a full edge commutator like this: 1, 2, 3, 4, 5, 6, 7, 8, no cancellations. So directionality is important here. So the other cases where you might want to continue at marginal cost is where your bad edges form a pair. Here's a bad edge and corner pair. In this case, my U move is bringing them together. It's going to be +4 to fix this. So 1 and then +1, 2, 3, 4. And that's actually the same whether you're regardless of the directionality. So here I have Here I have a U move that takes my bad edges away from each other, but I'm still forming a bad corner edge pair here, and this is going to be 1, so that's +1, 2, 3, 4, also +4. Let's look at ways in which you might set up your bad edges to form these bars before the first quarter turn. It's pretty intuitive to see that if you have one bar set up already, then the other bad edge has to be here, 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 or here, and you can always fix it with a slice. So it's either in the right place, or it's exactly a slice away, or if it's here, you can fix it with a U, slice U, or if it's here, you can fix it with an R, slice R. And you actually have another option here, because R slice R might cancel if you had an R to set up the corners, but if you used an F to set up corners, it wouldn't cancel, so that would be +4. But in that case, what you have instead is you can cancel with this R, with this F, and you can do F, U, F, U, F, U. That's another way to set that up, and that could cancel up to 4, so that would be a net +2 instead. What might not be so familiar is how to fix the bad edges using corner swaps. So to do that, what you need to note is that if I rotate my cube so that the bad corners are on the R and F faces, so in that case they're like this, and I make any FRF corner swap, then I've rotated them like this. So I go from here to here. And that's true for FRF and RFR. And I can widen any of those moves. So FRF, where that's any of them can be widened, that's 8 possible. RFR, where any of them can be widened, that's another 16 possible. So you're not going to memorize all of those cases, but you can intuitively find them by knowing how the corners are going to go, and then seeing how the edges get manipulated in the slices if you widen the moves. So the super useful result is that any 2, 0 bad edges can be fixed using exactly one corner swap. Let me just run through how those work. Here's my bad corners, and so 2, 0 bad edges can be only 4 possibilities. They can be here, 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 and here. So if they're here, look at what's going to happen after a corner swap. So my corners are going to be here, which means this is in the right place, and this needs to go down. So that means this is an F2, R2, F2. That's that case. So if my bad edges are like this, then again, after a corner swap, this is going to be in the right place, but this needs to come down, which I can do by widening the final move. So F2, R2, F wide 2. Now I have my bars. If my bad edges are here, then again my final move is going to want to be widened, and this one can be brought over here by widening the middle move. So F2, R2 wide, F2 wide gives me the bars. And then finally, the fourth case is when my bad edges are like this, and in that case, this needs to go across and this needs to go down, which is F2, R2 wide, F2. A corner swap is either going to cost +3 or +1 if you get a cancellation. You may have noticed that all those fixes started with an F2 move, so I have a 1 in 4 chance of getting a cancellation in this case. The generalized way to recognize that is if I set up my corners such that I have my 2 bad edges on the same face, then if my setup move was on a face that had 3 bad corners and the 2 bad edges are on the face where there's currently 1 bad corner after the setup, then I have a +1 fix. So that was all for 2 bad edges. Let's look at 4 bad edges. I think everyone will recognize this trigger as well. So this is the happy case for 4 bad edges. I have this bar, I have this bar, and then I have the 2 bad pairs like that. So that is a U, L2, F2, U. And directionality is important again. So here I have these 2 bad edges and these 2 bad edges. And the corner move I need, the U move I need for the corners brings them together. If I bring them apart, so here I have 2 bar slash, but this brings them apart. This is a terrible case. It's another +7 to fix. So, but I have a hope here to fix this one with corner swap, because if you note, this 2 bar slash is actually in the right direction if my corners were this way instead of this way, which means all I have to do is preserve these edges while making a corner swap. That's easy to do. That's and actually is a 1 in 2 chance of this canceling instead of 1 in 4. So I can set those up with an RFR, right? And now I'm in the happy case. and that R can actually be widened too. So I can do R wide, F2, R wide. So there's two set of moves that gives me a cancellation to a cheap fix. The other case that can be fixed is when you have 3-1 bad edges. So here I have 3-1 bad edges, and if I make a corner swap, I can, so let's look at, if I make a corner swap such my edges are here, then I want, all these three will be in the right place, and this one wants to come down. So F2, R2, F2 is enough to fix that into good edges, and that's 1 in 4 case, chance of having a cancellation. And then here are some cases where you might consider continuing without fixing if you have the moves to spare. So this is a 2-2 bar slash where the directionality is right, but you don't have the bars, but I'm still bringing them together, so that can be fixed after the first quarter turn. So that's U, F2, B2, and then a slice. The other one you can fix is a 2-2 plus. So 2-2 plus in any orientation can be fixed. There's the after the first quarter turn, U, B2, and then here we have R2, B2, R2. And interestingly enough, 0 bad edges can also be fixed for 3 after the first quarter turn. So this is the case where U, F2, RFR.
Let's move on to 3 quarter turn cases. There are 4 possibilities. The 2 bad corner one has 2 single move transitions, so this would be like U, R2, U, R2, U. This is fake HTR. It has 2 3 move transitions, so like U, R2, F2, U2, F2, U, R2, U2, F2, U. And then these 2 have 1 of each, so this is a 3 move followed by 1 move, and this is a 1 move followed by a 3 move. So these are actually inverses of each other, these 4 bad corner cases. I'm going to start with this one, and I think these 2 bad corner cases are probably the most likely for a random DR to be in one of these 2 states. So the easiest to recognize good edge cases for these corners are these symmetric ones, where you form a 2x2 block. So here's 2 bad edges that form a 2x2 block. Here's 4 bad edges that form 2 blocks. And this corner case is either going to be solved by U, R2, U, R2, U, right? That's HTR. Or it could be solved by U prime, F2, U prime, F2, U. But if you choose the wrong one, you're going to be fake HTR. So here's fake HTR because I did the wrong direction. So you have to know which one you're in, but the nice thing about the symmetric cases is it doesn't matter because they're symmetric, so one of them is going to work. So this one has the direct solution, U, R2, U, R2, U. And then this one has the direct with 1 extra turn, so U, R2, and then I have the good bar slash for the 2 QT case, so U, F2, R2, U. If you have 2 corners but they're split 1-1, then it's not symmetric and the directionality is going to matter. So what you want in that case, so say you have your bad corners, your bad edges like this, what you want is for your first move to separate them from each other. So I want these bad corners to move away from each other, and then it's going to be a good case. I mean, I still have the option of correcting this with a slice. That might be plus 2 moves, but it's still going to be good if the directionality is right because I can go U, then I can go R2, and then I have good edges for my 2 QT case, U, B2, R2, U. If my directionality is bad, so like here's a bad directionality because my U is going to bring these 2 together. Again, I still have the option of fixing it with a slice, but the other thing I can do is I can actually change the directionality with a move that doesn't affect edges or corners. So if I insert just a B2 here, then my U, R2, U, R2, U is going to be fake HTR, and the correct one is going to be U prime. So U prime, F2, and now I have the good edges. So U prime. The other case with 4 bad edges that's good for these corners is 3-1. And the idea is basically because you want to enter the 2 QT case with 2 bad edges because those have the cheapest fixes. So this is where it becomes handy to be able to like quickly recognize whether you have a fast fix, a cheap fix, or an expensive fix. So for example, here's my 3-1 edges. If I do my U, there's R2, and if I do L2 instead, then I've got good edges for the 2QT case. Just going to work through another one. So here's another 3-1 bad edges. They're like here. And if I do a U, now I'm using that trick. I'm going to set up my corners using the edge, the face with 3 bad corners, and I'm going to look for to see if I have 2 bad edges on the face that started with 3 bad corners. So in that case, that's going to be U, and I'm going to go R2, and there are my 2 bad edges, and they're on this U face. So that means there is a cheap fix, and that's going to be, in this case, B2 L2, and so that's a +1. Here's a case where that doesn't work out. So here I have 3 bad edges and 1 here, and if I do my U and then I set up my R2 using the face with 3 bad edges, then I see my 2 bad edges are split 1-1, and that's going to be not a cheap fix. Well, I could do that. It would be a 2-move fix with a non-canceling slice. So look out for those. All the other like 4 bad edge cases, they need to be fixed basically into 3-1, except for that symmetric one that we talked about at the beginning, because everything else leads to 2 QT case with potentially very expensive fixes.
The next 3 QT case to consider is this one. This is the one where it looks like you are 1 away, but if you solve the corners with 1 quarter turn, you actually end up in fake HTR. So what you have to do instead is a U move, and then a U R2 to F2, which actually looks like the same corner case, but now leads to true HTR.
The thing to know about this case is that an R2 to F2 can preserve your bars. So if I have my bad pieces set up like this, but I need to do my R2 to F2 to avoid fake HTR, then I can preserve the bars with that by choosing, in this case, R2 to F2, and now I have real HTR. And it works for the 4 bad edge case here. So these look like good edges for a 2QT case, except I need to do an R2 to F2 move first. So if I do that starting with this one that has 2, then R2 to F2, I'm still have good edges, and I can actually reach HTR quickly. So that means that the best and easiest to recognize cases are ones that lead to a good-looking 2QT case where you just preserve the fact that it's good with that R2 to F2 transition. So for example, here's a 3-1, so 3-1 is going to lead me to 2. If I do a U, then I have good-looking corners, and as I can do R2 to F2, get HTR. If I have 2-2 bars, 2-2 bars is going to lead to 2-2 bar slash, which is good for a 2QT case. So 2-2 bars, U, that's a good-looking case where I have to preserve the fact that it's good after that transition, which I can do, and then that's real HTR. And then, of course, I can enter a pretty good-looking case by starting with 2-0. So I can start with 2-0 and then U. So this isn't immediately set up, but it is a cheap fix. So here I've got my two bad edges like this, but I can do a corner swap F2 R2 F2 to fix, and then that F2 will cancel with the F2 to R2 transition that I need to make. So this is actually just a +1. The last 3 QT case I'm going to talk about is this one. It's the inverse of this one, and it's the one that leads to this U R2 to F2 corner case. The thing to know about this one is in the 2 QT case that it leads to, the only good cases are 4 bad edges. So you want to enter in 4 bad edges, which means that the good ones here are any 2-2 or any 1-1. 2-2 plus is good, 0 is good, but there are lots of ways to enter the next case in with four bad edges. So here are a few different ways you can enter the 2QT case with 4 bad edges like you want. So here's our 2 bars. You want to be able to set them up so that when you put your corners and slashes, you can still have bars or bar slash. So in this case, that U prime L2 gives me the ability to go U and then L2 U2 L2 F2U. That works. Here's a 1-1 case, so that's 1 bad edge and 1 bad edge, and I can get again a U prime, and now I have 3-1, and if I do either one of these, then I have my those are 2 bars. So then when I go U, I have R2 U2 F2U to HTR, and then here's a case where I actually have 0 bad edges, but this is still good because I can go U, and now I want to set up bars by going F2 R2 with the corner swap there. Now I've got bars, and so then I've got U R2 U2 F2 U to HTR.
So those are the core corner cases. For everything else, it's going to pass through one of those corner cases. And solutions get long. So it's really mostly about recognizing when you have a fast fix to a good edge case for one of these core corner cases. And also, since the solutions are long, you want to make sure you're preserving pairs or forming pairs. You might rarely want to spend time on this 3QT case. That's a fake HTR. You have a minimum 9 moves. The strategy would be kind of similar to this one. You just want to enter here with 4 bad edges that you can set up to the bars or bar slash. More commonly, you might take this QT case and turn it into a 4 QT case. If the edges are all expensive to fix, set up your corners like this, and if you can enter a good 3 QT case, then you might have a cheap continuation. And the most common and cheapest 4 QT case is this one. So let me just illustrate a few cases on how to approach that. When you're at a 4QT case, almost any edge configuration will somehow lead to a good 3QT edge case. So it's just a question of being able to fix those quickly and recognize those. So for example, here's a 4QT case. What I want to do is keep these together on the first quarter turn and then separate them. So I'm going to start with either a U R2 or a U prime R2. So I can say I can start with the U R2, and then I can notice, that gives me 2 plus edges. So that's not good. I want to fix that to 3-1. 3-1 is the good 4 edge case there. So instead of R2, I can do F2 R2, and then continue from there. I can also do B2 R2. That gives me 3-1 edges, so I can continue from there. If I do a U prime, R2, then I already have 3-1 edges, so that would be an easy continuation from there as well. So in that case, that would be a slice fix. Here's the same corner case with 4 bad edges, and I have many ways of continuing this. So for example, if I start with the U R2, then U R2, that gives me 3-1 edges, so that's good. F2 R2 is also 3-1 edges. B2 R2 is also 3-1 edges. Also L2 gives me 3-1 edges. F2 L2, B2 L2. So all those are good. In this case, if I wanted to start with U prime, then an R2 doesn't give me 3-1 edges. I have 2 bar slash, so I need to do corner swap to get F2 L2. Then I've got 3-1. B2 R2 also works, and F2 L2 and B2 L2 all give me viable edge cases. So that's the overview. A lot more details in the doc that's linked in the description. What you should be able to do, if you can recognize these cases, is to take any DR, set a target move count, say 10 moves, and write down all the HTRs within that move count in a couple minutes or so. And I'll have some follow-up videos where I go through that for some example scrambles. Hope you find this useful.